Kia ora koutou. This video is for Ben, Tosif and Snehal, Mr. Hawke's class, and anyone in my class resitting AS, and also for any randoms out there doing the AS exams. So I'm going to start going through the March 2020 paper. That should say stats, not pure, because that's what this is. So it's the first 3 questions from that paper. One is about perms and cons, one is a probability distributions question, and one is a normal distribution question. So all of the skills in this video cover things that are absolutely fundamental to passing Stats 1. So you need to make sure that you're completely on top of this content. You're not going to get that from just watching one video. Please make sure that you have got a pen in your hand as you're watching and that you're actively doing the questions to get it into your brains. Okay, so let's start out with question 1. We've got 40 members of a club, including Ranouf and Syed. All 40 members are travelling to a concert. So 35 of them are going in a coach, which is an English word for a bus, and the other 5 will travel in a car. Ranouf will be in the coach and Syed will be in the car. So in how many ways can the members who will travel in the coach be chosen? So this is just a little perms and cons question that isn't too hard. It's feels to me like it's a warm-up question for the rest of the paper. I like to do a little bit of writing about what I'm doing and why, and some wee diagrams. So there are going to be 35 members going in the coach, but we know that Ranouf will be in the coach, and we know that Syed will be in the car. So we're really only choosing out of 38 people. So it looks like this. So the coach is going to have Ranouf and 34 people. And then the car is going to have Syed and 4 people, but we don't even really care about the car, right? That's just something else in the question. In how many ways can the members who will travel in the coach be chosen? So I don't care where they all sit. There's nothing about the back seat or the front seat. So the order is irrelevant. And I can't choose Syed because he has to go in the car, and we know that Ranouf is going to be in the coach. So all I've got to do here is I've got to do 38 choose 34. It's a combination, not a permutation, right? So you must show that working, and then I always like to just go over what the definition of a combination is, because sometimes we're going to need to use that, right? So 38 choose 34 is this thing here. Now that simplifies as follows, and again, you don't need to do this unless you're obsessed with simplifying fractions like I am. A lot of stuff simplifies away in here, and here I've just got 4 times 3 times 2. So that gives me 73,815. It is totally fine to go from this step to this step, but you must show this or you will chuck a mark away. So that's the first question done, so pretty good. Right, the next one. An ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. So you should be thinking at this point that this is going to be some kind of geometric distribution question. But the easiest way to do this one is to visualize a tree in your head. So we're going to find the probability that it takes at least 3 throws, but no more than 5 throws to obtain a 1 or a 6. So over here, I'll just get rid of this big mess. I'm going to sketch out how I think about the tree diagram so that we can quickly go to the probability. So we've got not a 1 or a 6, and then we've got not a 1 or a 6 again. And then we've got either that they get it in 3 goes or they don't. So it looks like this. And then we've got for 4 goes. So we could get it on the 4th go or we could get it on the 5th go. Now, you don't even need to put the probabilities on and do it all properly, but I find that just doing that makes it really easy for me to think about what are the chances that it takes. So if it's at least 3 throws, but no more than 5 throws, what I'm looking for is the probability that it takes 3, 4, or 5 throws, right? I'd like to see when I'm marking this, not that I am marking this, unless you're Arnav, and the other people who are going to have a go at this paper in my class, I'd like to see a probability statement like that one, right? And then if it's 3 goes, that means I had 2 fails to start with. So 2/3 squared times 1/3. If it took me 4 goes, I had 3 fails and then success. And if it took me 5 goes, we had not 1 or 6 4 times 1/3. Now you weren't asked for an exact value here, but I just naturally will do this with fractions. So we've got 2 squared is 4, so 4/27 plus 8 over 3 to the power of 4 is 81. Plus 16 over 3 to the power of 5, which is 243. Cleaning that up, we get this. So we get 81 plus 24 plus 16 over 243, which gives me 76 over 243, or 0.313, to 3 significant figures. Be really careful that that's what you're rounding to if you're doing approximate values. I'm pretty sure you would have got a tick for leaving it as 76 over 243 as well. And again, you weren't asked for the exact value, so you must go to 3 sig figures if you're using an approximation, but you can give an exact value as well. Okay, and just the only thing I didn't say in there is that obviously that 1/3 number is coming from the probability of a 1 or a 6 is equal to 2 things out of 6 that could happen. So that's 1/3. Right, so that's the first part of the question. And then we're given a second probability question, which is going to be a binomial question. And it's going to be a binomial question because we're told that now we are throwing the die 3 times. So we've got a fixed number of trials. And the random variable is the number of times that we're getting a 1 or a 6. So the situation we're working with now is a binomial, and n is 3, and p is 1/3. So we have to draw up the probability distribution table for x, for 3 marks, and then we have to find the mean of the distribution. Now, the mean of the distribution, I've actually, in my work solutions, I've done this a really slow way, but because it's binomial, that means that we know very easily that the mean of the distribution is NP, which is 3 times 1/3. So 3 times 1/3 is just 1. 1/3 times 3, which is 1. However, I've done that the slow way, which is to use first what I do in the table and then find the mean. I'm going to put that in this video because it's a skill that comes up often anyway. And if you don't have a nice distribution, you usually will have to do some work to find the mean. And just while I'm going over this, we weren't asked for this, but if I had to find the variance of a binomial, it's just NP times 1 minus P, which would be 2/3 in this case. Okay, so and especially if you're watching this and you're doing A-level this year, you will often need to do those calculations before you do any weird approximation things. Well, actually, not weird approximation things, but things that if you're just doing AS, you can not worry about. So the table, it's important that we set it out well, right? And I want to see working for where the values come from. So the way that I did this is I actually did 3 layers of my table instead of 2. What are the possible values if I'm throwing the die 3 times? Well, I could get a 1 or a 6 no times, or once, or twice, or 3 times. Here, I'm going to put the probabilities before I simplify them. Right, so when I'm doing the binomial, I'm always thinking about Pascal's triangle because that shows me how many ways things could happen. So how many ways are there to get no 1s or 6s? It's going to be 3 fails. So there's one way for that to happen, which is fail, fail, fail. Right? So 2/3 cubed. How many ways are there to get 1 or a 6? Well, there are 3, right? It could be on the first, the second, or the third throw. So it's 3 times 1/3 for the success, and then 2/3 squared. How many ways to get 2 successes? There will be 3 ways times 1/3 squared times 2/3. And there will be 1 way to get 3 successes. All right, so I'm pulling those from there. 1/3 cubed. And now down here, I'm going to just simplify those probabilities and put them as fractions. So that's going to be 8 over 27. This one is going to be 3 times 4, 12 over 27. And this one is going to be 6 over 27. This one's going to be 1 over 27. It is totally fine not to simplify that fraction. In fact, if you look in the mark schedule, they don't simplify the fraction. And that's about the only place that you'll see in maths that it's useful not to simplify. And the same with this one. We could simplify both of them. It doesn't matter if you do, right? But no need. So secondly, I've already talked about how we can find the mean of a binomial is just NP. But the way that works for all discrete random variables, of course, is this, that the expected value is just weighting the outcomes by their probabilities. So if we do that in this case, we're going to get to 1, but let's look at how we do it. So we take this and we times it by this. We take this, we times it by this, and then we add them all up together. So let's do that very quickly now. So here we're going to have 0 plus 1 times 12 over 27 plus 2 times 6 over 27 plus 3 times 1 over 27, which, ta-da, gives me 12 plus 12 plus 3 over 27, which equals 1. So a nice question that you might be asked to do, which wasn't here, is show that the mean of the distribution is what you get from the binomial distribution formula, and that's what you would do to do that. Right, what have I got left? I think I've got one question left, which is on the normal distribution. And I've left one page of that working somewhere else. Nope, I think I've got it. Right, so let's go back and look at the question for the last one. Just got time to get through it. It's all about apples. So the weights of apples of a certain variety are normally distributed with a mean of 82 grams. 22% of these have a weight greater than 87 grams. So let's start by writing out what we know about X, which is the weight of the apples. So X is distributed normally with a mean of 82 and a variance, which is the second number I'm always given, of something that we don't know yet. The probability that X is greater than 87 is equal to 0.22. I'm going to do lots of pictures when I do this video, and I'd like to see lots of pictures in your working, right? Because they might feel like they're slowing you down, but they actually are going to mean that you figure out the right things. So we've got 0.22 is the area under the curve above 87. What we have to do is to work with the standard normal distribution with a mean of 0 and a variance of 1 and figure out what is that Z value there that is going to match up to the 87. So if I've got 0.22 here, that means that in all of this area here, the area is 0.78. So what I'm looking for in my normal table is this thing called phi. So phi of little z has got to equal 0.78. So I'm hunting through my normal tables, which I think I haven't popped into the OneNote, but I'll try and just quickly transfer over. There we are, there's the normal table there. So I'm looking for 0.78, no, not 0.78 in here. So I'm hunting through here, and you can see that it's coming in at 0.772. Now, I don't think I can write on the screen, but I'm using a little add factor to get exactly that 0.78 number. So if you look at 0.76, you're too low. 0.77 is too low, but 0.78 is too high. So it's going to be in between those two things. And that means that the Z value here works out to be 0.772, right? That's using that very last column to fiddle around and get it dead right. And that's telling me that this gap here of 5, so we're using now the formula of this. Z is equal to x minus mu over sigma. So 87 minus 82 divided by whatever sigma is has got to give me 0.772. So sigma is equal to 5 over 0.772, which is 6.48. So the intuition behind that is that when I am 5 above the mean, because I know that I'm cutting off 22% in that tail, 5 has to represent just over 3/4 of a standard deviation. Right, so 5 above the mean represents 0.772 standard deviations, so I can back it out from there to get 6.48. Now, how does that help? Well, that's all I had to do, right? Find the standard deviation of the weights of these apples, so we're done. Sometimes we'd have to go on and use that to solve a problem. This is a really common format for merit questions in level 2 probability, which I know you're still working through. Now then, the next question is easy once we've got that. We just have to figure out the probability that the weight of a randomly chosen apple differs from the mean weight by less than 4 grams. So drawing a nice picture, what have we got? Well, now we've got 82 here, and 4 grams either side of that gives me from 86 to 78. So we want to find the probability that X is between those two values. We know by symmetry that that's the same as being between 82, what am I doing? Yeah, so it's the same as X being between 82 and 86, doubled, right? So we're just going to find that area and then we're going to double it. We're going to use Z equals X minus mu over sigma, but now we know what sigma is. So Z is going to equal 86 minus 82, so 4 over 6.48, which is 0.6176. So we are looking for this area in here. So my whole thing is going to be 2 lots of phi of 0.6176, but I want to take away the half, right? So we don't want that half in there. So when we go back to our normal tables, the number we're going to get over here is 0.7317. I really wish I could draw on that screen, but I know one of you knows how to do that, but I don't.